Hello everybody, it's Mrs. Pound and we are studying weather from chapter 5.2 right now. And our topic for this video is precipitation from section 5 to 6. So our objectives today are going to be to compare relative humidity in warm and cool temperatures, describe the process of cloud droplets becoming precipitation, and to correlate precipitation types to atmospheric conditions. Okay, so we really need water on our planet, and water is super important. God provided us with water because life requires water. And so um, let's first talk about humidity with precipitation. Now, humidity is the amount of water vapor in the air, and you know that in our area in western New York, it can become very hot and humid in the summer, and it tends to be very dry, humidity wise, in the winter. So let's take a look at what's going on there. So when we talk about humidity, we're always talking really about relative humidity. And relative humidity is the amount of water vapor in the air compared to the amount that the air can hold at a particular temperature. Air holds different amounts of water vapor at different temperatures. So when we have 25% relative humidity, what that means is the air is holding 25% of the water vapor it could hold at that temperature. So at 25% relative humidity, it could hold a lot more water, really. Now, warmer air can hold more water vapor. That's why if we look in the back here, the background, with the rainforest, it's very hazy, it's very humid, and that is because that really warm tropical air can hold a lot of water vapor and become very humid. Now, if two locations have a relative humidity of 25%, air at 36 degrees Celsius holds more water vapor than air at 15 degrees Celsius. So at 36 degrees Celsius, it's going to be much more humid. And the reason you feel all sweaty in the summer here when it is hot and humid is because the more water vapor there is in the air, the less water vapor will evaporate from your body. And so then sweat, and sweat is when it evaporates is meant to cool you, the sweat stays on your body and you feel extra warm. When I was out west in Nevada, where it's very desert-like and very dry, it would be very hot out, but I would feel relatively cool because as soon as I would sweat, the water vapor would immediately evaporate from my body, and so I would not feel as hot and sweaty and icky out there as I do here. But the thing you have to be careful out there then is that because you are sweating so much and not really realizing it, you can become dehydrated very quickly. The last thing I want to mention about relative humidity and what it has also to do with our weather is that when we have 100% relative humidity, we're going to have precipitation of some kind. So it requires 100% relative humidity for it to, say, rain out. Okay, so that is important. Also, what is important with precipitation is there is something called the dew point. When the temperature reaches the dew point, you will have precipitation of some kind. And when the temperature is at the dew point, that means that relative humidity is 100%, so it is going to precipitate. Okay, so dew point is something important. Now, let's talk about coalescence. This is the process of coming together. It is important when we're talking about precipitation because cloud droplets become precipitation when they increase in size through the process of coalescence to become large enough to be affected by gravity. In clouds, they're too small to be affected by gravity, so they must coalesce and come together. Now, some forms of precipitation that we're going to talk about. The first is sleet. This starts in warm clouds as rain, but passes through freezing air and freezes again before it hits the ground. Um, Sleet is when we have basically small little ice pellets coming out of the sky. Okay, it's not snowflakes. It's not rain. It's like these, and it's not hail. It's not big enough to be hail, but it's those small little ice pellets. That is sleet. Freezing rain starts as a liquid but passes through air that is almost freezing. It freezes when it makes contact with the surface. And so here, can be very pretty. Freezing rain can be very pretty. It's coating the tree in the background, but it can also be very dangerous because if it gets on our roads, we have glare ice and we don't realize that it is there, and it can cause a lot of accidents. So freezing rain, remember, the key here is it does not freeze until it contacts the surface, where sleet freezes before it hits the ground. There's also snow. This starts in cold clouds as ice particles and stays frozen all the way to the ground, so it's always frozen. And we also have hail. This is precipitation in the form of ice lumps. What happens is there are convection currents. This is going to happen in your cumulonimbus clouds, your really tall, violent storm clouds. There are convection currents that carry rain droplets up to altitudes where they freeze, adding layers of ice. And what it does is it keeps carrying them up and up and up again, and it adds multiple layers of ice until you can get pretty large hailstones. You can have hailstones as large as golf balls. Now, not all precipitation necessarily falls out of the sky. Some of it just forms on the earth. I talked about the dew point. Where that comes from is dew, that in the morning it's very cold generally, and so you will be at the dew point and you will have dew on the ground just coming out of the air. It just, condensation comes out of the air, and that is dew. There's also a process called deposition. This is the changing of gas directly into a solid, and this is what happens when we have frost. We're at the dew point, it's cold, but it's so cold that the dew is basically frozen, but it doesn't pass through the liquid stage first. It just comes out as a solid, and that is what frost is on the ground when it is cold enough. Now, if you're listening, what I want you to do is by your name, I want you to either draw or write the name of your favorite type of precipitation. So our objectives today were to compare relative humidity and warm and cool temperatures, describe the process of water droplets becoming precipitation, and to correlate precipitation types to atmospheric conditions. So don't forget your 5 questions, and we are about halfway through our chapter on weather. This is a really long chapter, but weather tends to affect our lives quite a bit, so it's a really important chapter